So in this video you will see the results of the forward kinematics and the inverse kinematics of our robot arm. But before that, let's start with our simplest example that I did 1 year before. So this one. It's a simple example. This is, you just turn this θ1, you follow with me in the screen. So I turn the θ1 and you see the angle changing. This is the base of our robot arm in the beginning, like 1 year before. We have just 3 axes, and this is the second axis. It's you can see it like this one in our robot arm, so this axis. And then you see the other axis, so this one, that is responsible for moving this forearm. So this is our guy. So then I can change again the base. You see, I can turn the base, and I can turn the shoulder, and I can turn also the forearm. This is what we call forward kinematics. So when we specify the angles, and then the robot will follow the angles that we specified, and it moves to those angles. But in the reality, we don't want to just move the angles like this. We want for the robot arm to go to some position in the space. So we specified X, Y, and Z coordinates of this point, for example, the end effector. And we want the robot to be able to figure out what are the angles that needs to be applied to the different part of the robot to reach that coordinate of X, Y, Z. And to do so, it's different. And that problem is what we call the inverse kinematics. So with the one coordinate data point, we want to figure out what are the different angles that needs to be applied to the different parts and stepper motors here to reach that coordinate. So I will reset the view. Here you see I reset to 0 everywhere. And then here let's try to put some numbers like X, Y, Z, and then the model inside that I built will figure out what are the angles and the possibilities of angles that needs